learners, welcome to today's mathematics lesson. My name is Morgan Chiwe. Our mathematics lesson today is on earth geometry. At the end of the lesson, you should be able to identify the parts of the earth. You should be able to state the points as well as the location of the points on the earth's surface. 3. You should be able to find the latitudinal difference as well as the longitudinal difference of the points on the earth's surface. And lastly, you should be able to find and calculate the radius of the circle of latitude. Now, let us get into the details of our today's lesson. The word earth geometry, it's two words in one, but our focus will be on the geometry, because we know from the basic geography that the earth this is where we are, and from the universe we are able to understand what earth is. But to talk a little bit more on the earth geometry, the word geometry is a Greek word which is made up of two words. There is what we call jaws. You can say jaws, which means earth. And then the other word is metri. In Greek we say metron. Metron, which means measure. So combining the two words, jaws as well as metron, it means we are looking at the earth measure. So basically, earth geometry is all about the measurement of the earth, where we measure the distances on the earth's surface. And now, since we have understood what geometry and earth geometry is all about, we can go into details and look at the parts of the earth. Now let's look at the globe and see the parts of the earth. This is the earth. As you can see, the earth has the lines. These lines are what you call the longitudes from the basic geography, and the other lines, as you can see, these which are latitudes. Then as we look at the shape of the earth, you can see that the earth is spherical in shape, and as you can see at the ends, this end as well as the other end, these are poles which are slightly flattened. But for the sake of measuring distances on the earth, we will consider the earth to be a perfect square, a perfect sphere. So now, since this is a perfect sphere, we can identify that some of these lines which are on the earth, these are imaginary. And since they are imaginary, some of the pairs, these that we are looking at to be longitudes, the pairs of the corresponding pairs of longitudes, they make the complete circle, which is just the same as that of the sphere, which is the earth. And these that we are looking at, which are latitudes, they vary in terms of their circumference. So we can see that, as you can see from the poles which are flattened, the polar circumferences, they are shorter in radius. The circles which are shorter ones in terms of their radii at the poles, you discover that they keep on increasing in radius, as they go towards the equator, which is just this latitude down there. So you discover that they are varying, the latitudes or the circles of latitudes, they vary in terms of their radii. So we can simply say that on the Earth's surface, there are circles that are small circles and those that are great circles. But apart from the equator, which has the radius equal to that of the Earth, all pairs of longitudes, they are all great circles. These parts, they help us to locate as well as to find the distances of places on the Earth's surface. Now let us list the parts that we saw from the globe. We saw the North Pole. There was also the South Pole. We could as well identify other parts, all that are imaginary, the latitudes, the longitudes, we saw the equator, we saw the Greenwich meridian, and as we were identifying and looking at the parts on the globe, we said that all the latitudes, they are measured from the equator, which is the 0-degree latitude, either north or south of the equator. Then the Greenwich meridian, which is the 0-degree longitude, and all longitudes are measured from the Greenwich meridian, which is the prime meridian, and that is either east or west of the Greenwich meridian, up to 180-degree west or east. Just as we've already talked about the equator, also latitudes, they just move from 0-degree to 90-degree north of the equator, or 0-degree to south, due south, that is the South Pole, which is 90-degree south. So we can simply say that it's either 90-degree north of the equator or the 90-degree south of the equator. And that's how these latitudes as well as the longitudes are numbered on the Earth's surface. Now let's come to the location of points on the Earth's surface. As we've already identified, we've said that there are circles on the surface of the Earth, the small circles as well as the great circles. And we should bear in mind every time we are calculating distance on the Earth's surface. Let us have a look at the chart and see if we can locate these points that are on the surface of the Earth. Now, you can see that we have the lines which are imaginary. We have imaginary lines. These are the latitude 70 degrees, which is measured from the equator. And we have 30-degree south latitude, which is also measured from the equator. We also have the longitude NRXYS, which is longitude 80-degree east. And we also have the longitude NPZS, This is the longitude 40 degree west of the prime meridian, which is NQGZ, which is our Greenwich meridian or the prime meridian. G is the point where the Greenwich meridian crosses the equator. Lines of latitude 70 degree north and 30 degrees south, and longitude 80 degree east and 4 degree west are given as shown above, as we have discussed. Now, state the latitude and longitude of the following points. A, point P on the Earth's surface. Each and every point on the Earth's surface is completely defined by its latitude and longitude. So as you state the position of point P on the Earth's surface, you first start by looking at its latitude, and then you state its longitude. Let's look at the solutions. A, solutions, point P will be, you look at the latitude from the chart. P lies on the latitude of 70 degree north. So that means the latitude for point P is 70 degree north. Then the next thing is to look at its longitude. The same point P, this is the longitude, and that is longitude 40 degrees west. Say 40 degrees west. And therefore this is the point, the position of the point P on the Earth's surface. For point Q, which is part B, we can as well, in the same way, look at the latitude as well as the longitude of point P on the surface of the Earth. And the solution for the position of Q will be, from the information given, we've been told that NQGS is the Greenwich meridian, and we know very well, as we can see from the chart, that Q as well lies on the same latitude just as P, which is 70 degree north. Therefore, we'll say Q is 70 degrees north. The longitude, which is, from the chart as we can see, is the Greenwich, which is the starting point for all longitudes as 0 degrees. So we can say that the position of the point Q on the surface is 70 degrees north, 0 degrees. In like manner also, point R, you can see that on the Earth's surface, the same latitude just like point P and Q, but on a different longitude, which is longitude 80 degrees east. So we can simply say that point R is lies on 70 degree north, 80 degrees east. This is how we can locate points on the Earth's surface. Now let us look at question 2. Question 2 from the chart reads, what is the difference in longitude between A, X and Y, B, Y and Z? For us to get the difference in terms of longitude between 2 points, we need to state the location of those 2 points. So from the chart we can see point X. Point X from the chart lies on the equator, which is latitude 0 degrees. And the longitude for X is 80 degrees east. So we can write the correct position of point X to say that X is 0 degrees, 80 degrees east. Coming to Y also from the chart, we can locate point Y. Y lies on latitude 30 degrees. And the same point Y lies on the longitude 80 degrees. So we can simply say the position of point Y is 30 degrees south, 80 degrees east. So we can say Y is 30 degrees south, 80 degrees east. Now that we've come up with the positions of the 2 points, X and Y, we'll look at their longitudes in order for us to get their differences. You see that X, the longitude for X is 80 degrees east, and the longitude for point Y is 80 degrees east. So we'll say that the difference between 80 degrees east and 80 degrees east, this is now what we get. 80 degrees minus 80 degrees, we get 0 degrees. So we can say, therefore, the difference in longitudes, between X and Y is 0 degrees. Then we have stated and found the answer in terms of longitudinal difference between X and Y. Looking at part B, on the chart, as you can see, the difference between Y and Z in terms of their longitudes, we equally state their positions. Just as you can see, Y, you've already stated from the previous question in part A, the position of Y, which is 30 degrees south as well as 80 degrees east. Coming to the position of Z on the chart, you can see that it lies just on the same 30 degrees south, just like Y. This is point Z, and the longitude for point Z is 40 degrees west. So we can simply say that from there that the position of Z is 30 degrees south, 40 degrees west. So we can write and say that the position for Y, I'd already found it in part A, which is one and the same, 30 degrees south, 80 degrees east. For Z, as we've come up with, saying that Z lies on 30 degrees south, 40 degrees west. Remember, we are still looking at the difference in terms of longitude. So we are going to find the longitudinal difference between the 2 points. So we identify the longitude for point Y, which is 80 degrees east, and then the longitude for point Z, which is 40 degrees west. Now, the fact that Y and Z lie in different parts or on opposite sides of the prime meridian, so you discover that their difference will be the sum of their degrees. because this is east-west, which is 80 degrees east, then you'll be able to add the 40-degree west. Now, the fact that this is east, that is west, in terms of their difference, you are adding to find the difference. But always remember that when we are finding the difference will not have the direction to say this is east or west. So our focus will be on the actual degrees. So as a result, when we are adding, we will look at the 80 degrees as well as the 40 degrees in order to get 80 plus 40 to get 120 degrees. The degrees, the east and the west, are not the differences in terms of their longitudes. So we can simply say that therefore the difference in longitudes between y and z is 120 degrees. Remember, we've said that on the Earth's surface there are small circles and great circles, and the radius, the mean radius of the Earth is 6,370 kilometers. So measurements on of distances on the Earth's surface, it can either be in kilometers or in a special unit called nautical miles. What is a nautical mile or a sea mile? A nautical mile is defined as the length of an arc of a great circle which subtends an angle of 1 minute at the center of the Earth. So we can write the definition of what a nautical mile is or what a sea mile is. A nautical mile is the length of an arc of a great circle which subtends an angle of 1 minute. That is the symbol for 1 minute. We can write there and say 1 minute at the center of the Earth. From here we can see how we can get to convert the 1 minute in terms of degrees. As you can see, we were dealing with the degrees and also the circumference of the Earth, which is a great circle. On the conversion of minutes to degrees as well as the circumference of the Earth, we'll say that measurement of distances on the Earth from the Earth, and since the Earth is a perfect sphere, in 2 dimensions we'll consider it to be just a circle, which is a plane figure. So as you can see, this is a circle. Now we consider this to be the center of the Earth, and then the 2 radii. Now, according to the definition that we've just given on the nautical mile, we said that subtends an angle of 1 minute at the center of the Earth, and then the length of an arc becomes, that is the 1 nautical mile. So we can simply say that 1 nautical mile is equivalent to an arc length of 1 minute. But we very well know that for a complete revolution of a circle, the total number of degrees is 360 degrees. But we know that if you have an arc length of, let's say, 2 nautical miles, you have an arc length of 2 minutes. So as we continue building up from there, having 60 nautical miles, this will be equivalent to the arc length of 60 minutes. But we know that 60 minutes is equivalent to 1 degree, which is equivalent also to 60 nautical miles. So we can find the circumference of the Earth in terms of nautical miles, where we say that the Earth, being a complete sphere and two-dimensionally as a circle, is equal to 360 degrees. So in terms of the nautical miles, or length in terms of the nautical miles, we can now calculate. So if we cross multiply 360 degrees multiplied by 60, we get the circumference of the Earth in nautical miles. So we say circumference of the Earth will be 360 degrees multiplied by 60, which gives us 21,600 nautical miles. So we are getting the circumference of the Earth being 21,600 nautical miles. But remember, from the mensuration and from the circumference of a circle, the formula for that is C equals 2 pi r. We are using the capital R because it's a great circle, so we are using it to be also a great R or a capital R. So we can find now the radius of the Earth in nautical miles. Remember, we said that the mean radius of the Earth in kilometers is 60,370. But we can also calculate and get the radius of the Earth in nautical miles from what we have just derived here. We say that the circumference of the Earth in nautical miles is 21,600 nautical miles. It's equal to 2 multiplied by, we are going to use pi to be 3.142 from your calculator. Say 3.142 multiplied by r, where r is the radius of the Earth. So making r the subject of the formula, we have r is equal to 21,600 divided by 2 times 3.142. To four significant figures, as you calculate, you find it to be 3,437 nautical miles. And that becomes our radius of the Earth in nautical miles. Now, we can use the radius of the Earth being 3,437 nautical miles, as well as the 60,370 kilometers, to calculate the radius of any given circle of latitude. As we can see from the chart, let's have a look at the chart and see if we can calculate the radius of any given circle of latitude. From the chart, you can see we are looking at the radius of a circle of latitude. So we can say that the latitude of point P is theta, then C is the center of the circle of latitude on which P lies, as you can see on the chart. So we have, this is the North Pole, the South Pole. We have also the longitude where P and E lie. Then we have C being the center of this circle of latitude. Remember we said that all latitudes are measured from the equator. So if this latitude is theta degrees, it means it's from the equator theta degrees. You measure from the equator, it means it makes an angle of theta degrees. So from this sphere, as you can see, we can interpret by looking at the other part here, which is a plane figure, where we can easily now interpret that the radius of a circle of latitude, which is small r, Cp, and then we have also OE, which lies on the equator, and that is the great circle which will have the radius of the Earth. So from the center of the Earth, which is O, to any point on the circumference, it will still be equal to capital R. So from here you discover that since Cp and OE, they are parallel, and OP acts as the transversal, so there are angles that now be formed, which we may call angles associated with parallel lines. So we have theta here as well as the same angle theta, meaning angle CPO is equal to angle POE, which are alternate angles. So we can extract from here that this angle is equal to that angle. So from triangle OCP, as we can see from here, so that we are making an extraction from the chart where this is our R, that is P, that is our C, that is O. OP is capital R, and the angle at P is theta. This is perpendicular to the line joining all the centers. So we can now